Hi everyone, welcome back. In this module, we are going to continue our part B of module 13th of our Verilog HDL crash course. So in the part 1 of our module 13, we discussed everything about finite state machines in Verilog. And we covered Murray and Mealy Fsm in details in our part 1 of module 13th, and also there we covered what is the difference between Murray Fsm and a Mealy Fsm. So in this module, we are going to take one example of sequence detector, which is 1001 sequence detector, and we are going to implement the state diagram and the Verilog HDL code for this 1001 sequence detector in both Murray type of FSM and Mealy type of FSM. So friends, if you have not gone through the part first of module 13, I would recommend you to first go through that module so that it would be easy to understand the 1001 sequence detector which we are going to discuss in this particular module. So now let's get started. So here I am just briefly going to discuss about what we discussed in part first of module 13. So where we discussed about Murray FSM and Mealy FSM. So in Murray FSM, the output depends only on the present state. So this is the basically block diagram of a Murray FSM where we have three blocks: the next state logic block, the present state logic block, and the output logic block. So in Murray FSM, the output directly depends on the present state, and the present state is basically a sequential circuit, or in other words, the present state can only change at the active edge of a clock. So basically this is a registered output coming out of the present state, and hence the output logic is going to be less prone to any kind of combinational glitch. And the number of states which are required to code the Murray FSMs are going to be more than Mealy FSM. And this we are going to see by using 1001 sequence detector in this module. And Murray type of FSMs basically react slower to the inputs because here the output is not directly depending on the inputs. So the output basically reacts slower to the inputs. And in the Mealy FSM, the output actually depends on present state as well as the inputs. So here, since the output is directly depending on the asynchronous inputs, the output logic is going to be more prone to glitch, and the number of states which require to implement a Mealy type of FSMs are less compared to Murray type of FSM. And since the output directly depending on the inputs, that means the Mealy type of FSMs are faster to react to the inputs. And we also discussed in our previous module 13th part 1 that there are three techniques to implement FSMs in Verilog, where the first one is using a single process to implement the present state logic, the next state logic, and the output logic. And the second technique is using two processes, where one process is used to code the present state and the next state logic, and another one to code the output logic. And the third technique is by using the three process, where present state and next state and output logic will use different process. And the recommended technique is use three separate processes to code the current state logic, the next state logic, and the output logic. So guys, now we are going to take the example of 1001 sequence detector, and we are first going to write the state diagram of this sequence detector. So first we are going to cover the Murray type of FSM, and here we are going to take the concept of non-overlapping FSM. So first of all, let's understand what is overlapping and non-overlapping FSM. So let's take the example of the same 1001 sequence detector. So for example, we have a input sequence something like this: 1001 001 001. So this is the sequence which is basically input to our sequence detector. So if the sequence detector is a type of non-overlapping, then how the output of the sequence detector will look like? So if we give this sequence to our sequence detector, after 1001, here the output will be detected as 1. Now next is 001. So here again the output, the sequence will be detected as 1001, and here the output will be detected. So basically here this sequence that is the next 1001 sequence is not depending or not overlapping with the first 1001 sequence. And if our sequence detector output is something like this, it is nothing but a non-overlapping sequence detector. Now let's understand the overlapping sequence detector. Let's take the same example here, which is 1001 001 001. So if we give the same input to a overlapping type of sequence detector, then let's see how the output of the sequence detector will look like. So first 1001, so here our sequence will be detected and output will become 1. Then if you see again here after 001, again this is a new sequence where again the output will become 1. And now again 1001, the sequence is detected and here again output will become 1. So basically what is happening here is this 1 is basically overlapping with this sequence and this next sequence, right? So this kind of sequence detector is nothing but a overlapping sequence detector where the next sequence, some bits of the next sequence can overlap with previous sequence to detect the output. So this is nothing but a overlapping type of sequence detector. So if you see with the same input, if we use a non-overlapping sequence detector, the output will be detected at here and at here. But with overlapping sequence detector, there will be 3 outputs detected. One is here, one is here, and one is here. So this is the basic difference between a overlapping and a non-overlapping sequence detector. And I hope this is clear to you. Now let's concentrate the state diagram of Murray type non-overlapping 1001 sequence detector. So to write the state diagram, always remember that we have to follow some rules. So here, just don't see this state diagram. First, let's define the states for the sequence detector. So here we are defining the S0 state. S0 is nothing but the state where the sequence detector will go on reset. So when the sequence detector will start detecting the sequence, the first state at which it will be default is nothing but S0 state. And then whenever the 1 is detected, it will go to S1 state. And then whenever the next 10, this is our sequence detector 1001. So S0 is a default state. And from that default state, whenever 1 is detected, our sequence detector will move to the S1 state. And then if the next 0 is detected, then again it will go to the S2 next state, which is 10 is detected. And again if 1 is detected, it will go to S3 state, which is nothing but when 100 is detected. And then if again 1 is detected, that means 1001 is detected, that means it will go to the next S4 state where 1001 is detected. So this is how first we are going to define the states for this sequence detector. So this is a standard way of defining the state. So whatever sequence is given to us, we are going to take bits one by one and we are going to define the states like this. Now let's try to understand this state diagram. So this is our S0 state, and so if you see here, whenever we are at the S4 state, that means 1001 is detected, and if 1001 is detected, that means output at this state is going to be 1. Our sequence detector output at this state is going to be 1. That means whenever we are at S4 state, our output is going to be 1. So whenever, so first we are going to be at the default state, which is S0 state, and the output at S0 stage is nothing but 0. So you can say that at S0 state our output is going to be 0, S1 also output will be 0, S2 also output will be 0, and S3 also output will be 0, and at S4 state our output will be 1. So in starting we are at S0 state and our output will be 0. So if we are at S0 state and if suppose our input data is 0, that means that 0 is not part of our sequence first bit. That means we are always going to be in S0 state only if the input data is 0. And also whenever the reset is asserted, we are also going to be at the default state, which is S0. So here whenever 0 is detected, we are going to be in S2 state. But What if 1 is detected? If 1 is detected, that means 1 has detected, that means 1 is not part of our sequence, and the next one is basically now will become the first bit of our sequence. So we are again going to be on S1 state only if the next bit after first one is detected is again a 1. So I hope this is clear. So now let's assume that 10 is detected. If 10 is detected, we are in S2 state. Now in S2 state, there may be two cases. The next bit can be 0 and the next bit can be 1. Right? Now if 100 is detected, that means if the next bit is 0, that means we can go to S3 state, where S3 state is nothing but 100 is detected. So here we are, if 0 is detected, we are going into S3 state. But what happens if 1 is detected? That means we are in S2 state, and in S2 state the next bit is 1. So it will become 101. That means this is not a part of our sequence detector. Right? Our sequence detector is nothing but 1001. But if 101 is detected, that means our sequence is not going to be complete. So 1 is detected, that means this will start a new 1, right? Because this 1 is going to be now part of the fresh new sequence. That means if 101 is detected, we are going to be in state S1, because S1 is the state where 1 is detected. Now let's assume that 100 is detected. If we are in state S3, that means 100 is detected. So if 100 is detected, then next bit can be 1000 and it can be 1001. So if the next bit is 1, that means our 1001 sequence has been detected. And if 1001 sequence is detected, we are going to be in S4 state. And in S4 state, since 1001 is detected, the output is going to be 1. But what happens if in S3 state the next bit is 0? So if the next bit is 0, that means the sequence will become 1000, and this is not part of our any sequence detector, which is 1001, and hence we have to go to our initial default state, which is S0. And from S0 state we have to again wait for a next 1 to go to the S1 state. Now when we are in S4 state, that means our sequence 1001 is detected. Now if the next bit is 1001 is already has detected, the next bit can be 0 and it can be 1. So if the next bit is 0, and remember this is a non-overlapping sequence detector, so this sequence, none of these sequence bits are going to be part of our next sequence in the data stream. So if the next bit is 0, that means we have to go to our S0 state. But if the next bit is 1, that means the next, this bit, that is the fifth bit, can be part of our next sequence in non-overlapping case. So we are going to be at state S1, which is nothing but 1 is detected. So guys, I hope the state diagram of this 1001 sequence detector using Murray machine and with non-overlapping concept is clear to you. Now let's see how we can code this 1001 sequence detector in Verilog. So we are going to use the recommended method, where we are going to use 3 processes to implement the current state logic, the next state logic, and the output logic. So this is our Murray 1001 non-overlapping sequence detector, where we have the input clock, the input reset signal, the data input, and the data output. So these are our input ports, and this is the output port, and we have to use a register type of output because we are going to code the output logic in a procedural block. Here we are using the parameter method to define the state. So this is our S0, S1, S2, S3 and S4 state. So there are 5 states. So to define the 5 state, basically we need a 3-bit variable which will define the state and the next state logic. So first of all, we are going to implement our next state logic. So if our current state, the state is nothing but the current state or data input. So if our current state is S0, so if you see from the state diagram, from S0, if 0 is detected, the data input is 0, that means we are again going to be in S0 state only. Otherwise, if input data is 1, we are going in S1 state. So if data input, that means if data input is 1, we are going into S1 state, else we are going to be in S0 state only. Now if we are in S1 state and if data input is high, if we are in S1 state and the next input bit is 1, that means we are again going to be in S1 state only, and if the data input bit is 0, we are going into S2 state. So this is how, if the data input is high, that means we are going in the same S1 state, otherwise we are going into S2 state. And if we are in S2 state, then if our data input is high, we are going into S1 state. From S2 we are going in S1 if the data input is 1, otherwise we are going into S3 state. So otherwise we are going to S3 state. So if we are in S3 state and data input is 1, the next state is again going to be, so if we are in S3 state and data input is high, we are going into S4 state. This is a type of S4. Else we are going into S0 state. And if we are in S4 state and if our data input is high, we are going into S1 state, and if data input is 0, we are going into S0 state. And default we are going to be in S0 state. So this is our next state logic. Now let's see the current state logic. So whenever positive edge happens and there is a reset, so if there is a reset, we are going into default state, otherwise we are going into the present state will be nothing but the next state. And this is our output logic, where this is a Mealy type of Fsm. So in Mealy type of Fsm, the output only depends on the present state. So if our present state is S0, the output is going to be 0, as we discussed here, because here our output is detected in S4 state. So only in S4 state the output is going to be 1. So if you see here, whenever we are in S4 state, the output is 1, otherwise it will be 0. And default the output is going to be 0. So friends, I hope the 1001 sequence detector state diagram and the Verilog HDL code is clear to you. Now let's see the 1001 overlapping Mealy type of Fsm. So again, the state definition is going to be same in Mealy type of Fsm, where S0 is nothing but the default state, S1 is when 1 is detected, S2 is when 10 is detected, and S3 is when 100 is detected, and S4 is when 1001 is detected. So the only difference here is going to be respect to overlapping concept. That means let's assume the same example here which we discussed earlier. This is our input sequence, and so if it is a non-overlapping, then our output is going to be high here, and then our output is going to be high here. But it is a overlapping sequence, then our output is going to be high here as well as here also. Okay, so now let's understand in more details. So by default we are in S0 state. So whenever we are in S0 state and if the next bit is 0, we are going to be in S0 state. Whenever 1 is detected, we are going into S1 state. And if we are in S2 state, then if our next bit is 0, we are going into S3 state, otherwise we are going into S1 state. So now let's see when we are in S2 state. That means if we are in S2 state, that means 10 has been detected. So the next bit can be either 0 and it can be 1. So if the next bit is 0, that means we will be in S3 state. So we will be going into S3 state. But let's see if the next bit is 1. So if it is a non-overlapping concept, always try to remove the bits from the starting. So let's remove this. So if we are in S2 state and 101 is detected, then what will be our next state? So let's start removing the bits from starting. So let's remove this 0. Remove this 1. So now our sequence is 0 1. So is there any state with the 0 1? There is no state where 0 1 is detected. Now let's again remove the next bit 0. So now 1. So 1 is a state, S1 state where 1 is detected. So we are going into S1 state. Okay. Now let's see, we are in S3 state. S3 state, where we are in S3 state when 100 is detected. Now the next can be either 0 and it can be 1. So if it is 1, that means 1001 is detected and we are going into S4 state. But if the next bit is 0, that means 1000. Now what will be our next state? So just start removing the bits from starting. So first we will remove our 1000. There is no state where 000 is detected. Again remove the next bit. We are at 00. So there is no state with 0 0 as well. Again remove 0. So 0 means it will be a default state. So from S3 we are going into the default S0 state. Now when we are in S4 state, that means 1001 has already been detected. Now the next bit can be either 0 and it can be 1. So now let's see if the next bit is 0. So if the next bit is 0, then where it will go further. So let's start removing the bits from starting one by one. So we will remove our 0 0 0 1 0. There is no state with which can detect 0 0 1 0. Now let's remove the next bit as well. That means 0 1 0. There is no state with 0 1 0 as well, where 0 1 0 can be detected. Now let's remove this as well. Now 1 0. There is a state where 1 0 is detected. So we are going into S2 state. So whenever the 0 is detected, we are going into S2 state. That means this 1 0, that means this 1 of the previous sequence is going to be part of the next sequence. So now whenever 0 is detected, what will be the next state? S2. But what happens if 1 is the next bit? So 1 is the next bit, that means our sequence is nothing but 1 0 0 1 1. So let's start removing bits from starting one by one. So first remove 0 0 0 1 0 is the next sequence. No, there is no sequence which can detect 0 0 1 0. Again remove this 0 1 1. There is no sequence. Again remove the 0 1 1. Again there is no sequence. Next remove 1. It will become 1. So 1 is detected. S1 is the sequence where S1 is the state where 1 is detected. So we are going at 1. So guys, this is the difference, and this is how we can basically write the state diagram for overlapping and non-overlapping Murray type of Fsms. Now if you see here, the Verilog code is going to be similar to what we discussed for the non-overlapping case, but the difference is when we are in S4 state, and if the next bit is 0, we are going into S2 state, and otherwise if the next bit is 1, we are going into S1 state. So the difference here is only going to be in S4 state, where if data input is high, the next state is S1. If 1, if 0, if the next bit is 0, we are going to S2 state. So this is the only difference here between overlapping and non-overlapping Verilog HDL code of 1001 sequence detector using Murray Fsm. Now let's see the Mealy type of Fsm. So Mealy type of Fsm, first we are going to cover the non-overlapping concept. Okay. So first of all, we are going to define the states. So now let's define the states for 1001 sequence detector for a Mealy type of Fsm with non-overlapping concept. So our S0 here again is going to be a default state, and S1 is when 1 is detected, S2 is where 1 0 is detected, and S3 is when 1 0 0 is detected. So we are not considering the S4 state where 1 0 0 1 is detected. Okay, so this is how the states in Mealy type of Fsm is going to be less than Murray type of Fsm, because in Mealy type of Fsm we do not define a state for the exact sequence, and how we will detect the exact sequence we are going to see in this state diagram. So in starting we are in default S0 state. So as soon as the next bit is coming as 0, we are going to be in S0 state only, and if the next bit is 1, that means we are going into S1 state, and till now only the one of the sequence has been detected. That means our output is also going to be 0. So this is how we represent the output of sequence detector in Mealy type of state diagram. Here this is nothing but the output, and this is nothing but the input bit. Okay, so whenever from S0 state the input bit is 1, that means the first bit of our sequence detector has been detected, but only the first bit, so output is going to be 0. Okay, so when 1 is detected, we are in S1 state. So in S1 state, if the next bit is, so the next bit can be 0 or it can be 1. So if the next bit is 0, we are going into our S2 state, which is where a 1 0 is detected. So we are in the S2 state. But what happens if 1 1 is detected? If 1 1 is detected, then this one, the next one will be going to part of our new sequence, right? Because 1 1, our sequence is nothing but 1 0 0 1. So if there is 1 1, that means this is not part of our sequence. So the next one we are going to consider for our next sequence. So if 1 is detected, we are going to be in S1 state only, and again the output is going to be 0 here. Now if we are in S2 state, that means 1 0 has been detected. So the next bit can be 0 and it can be 1. So if the next bit is 0, that means this is part of our sequence and we can go into the next state, which is S3 when 0 is detected. But only the 1 0 0 is detected, not 1 0 0 1. So the output is again going to be 0 here. And if 1 0 0 1 is detected, that means this is not part of our sequence, and now this 1 is now next time going to become part of our sequence. So 1 is detected, then from S2 we are going to S1 state. Now if we are in S3 state, that means 1 0 0 has been detected. Now the next bit can be 0 or it can be 1. So if the next bit is 0, that means it will become 1 0 0 0. That means this is not our sequence and these all bits are not going to be part of our sequence. That means the next bit is 0 and we have to go into default S0 state. But what happens if the next bit is 1? That means we have detected our sequence. If we have detected our sequence, that means whenever the next bit is 1, that means the bit is 1 and it has completed our sequence. That means here the output is also going to be 1. And since it is a non-overlapping type of Mealy FSM, so we have to start the next sequence from the next bit. So whatever the next bits are there, the next sequence can be detected here itself, and none of the bits from this sequence are going to be part of our next sequence. So we have to go to our default state, which is S0 here. So this is how, using one state less, we are going to detect the output of our sequence detector using Mealy type of FSM. So if you see here, from S3 state we are going into S0 state only, but with the different outputs. Whenever 0 is detected in S3 state, we are going into S0 state, but the output is 0. But whenever 1 is detected when we are in S3 state, we are again going into S0 state, but our output in that case is going to be 1. So friends, I hope this is clear. Now let's see the Verilog HDL code for this FSM. So here we have the Mealy type of 1001 non-overlapping sequence detector. The clock, reset, data in and data out are our ports. And here we are going to first code our next state logic, where we have the state and data input in our sensitivity list of the procedural block. And whenever the present state is S0, based on the input data, it will be going into S1 or S0 state. From S1 it is going into S2, or if the data is high, it is going into S1 itself. And if we are in S3 state, if the data is high, we are going to S1 state, otherwise we are going into S3 state. And if we are in S3 state, if the data input is high, the next state is going to be S0, otherwise also the next state is going to be S0. Okay, so for both 0 and 1, if you see here, data input is both 0 and 1, but the output is different here. But in both the cases, anyway, we are going into S0 state. So first let's see the current state logic. The current state logic is very much similar. Whenever reset, we are in the S0 state, otherwise our present state is going to be the next state. So this is the output logic. So now the output logic is going to depend on both present state and the input. Okay, I hope it is very much clear, because this is a Mealy type of FSM, and in Mealy type of FSM the output depends both on present state and the input data. So if our present state is S0, anyway data is going to be the output of the FSM is going to be 0 0 0, both in S0, S1 and S3. But only when we are in S3 state and the data is high, the input data is high, that means the output is going to be high, otherwise the output is going to be 0. At default the output is going to be 0. So whenever we are in S3 state and if the input data is 0, then the output is 0, otherwise if the input data is 1, the output is going to be 1. So this is how we can code this output logic in Mealy type of FSM. Now friends, let's see the overlapping case. So in overlapping case, so the state definition is going to be the same in case of overlapping and non-overlapping, but only the state diagram is going to be changed. As far as 0 is detected, it is again going to be in S0 state. Else if 1 is detected, we are going into S1 state. So 1 is detected. Now the next can be 0 and it can be 1. So if the next is 0 is detected, then we are going into S2 state, otherwise 1 1. So let's start removing from the starting. Start removing the bits from the starting to determine the next state. So we will remove this, then 1 is detected, that means it is going to be in S1 state. Now if we are in S2 state, that means 1 0 has detected, the next can be 0 and it can be 1. So if it is 0, that means we can go into the S3 state, but if it is 1, that means start removing the bits from the starting. 1, remove 1, that means 0 1, there is no state with 0 1, remove this 0 1, there is a state with 1. So from S3 we are going to be in S1 state if 1 is detected. Now if we are in S3 state, that means 1 0 0 has detected. Now the next bit can be 0 and it can be 1. So if the next bit is 0, that means this is not the part of our sequence. So what will be our next state now? Start removing the bits. 0 0 0 0, no bit, no state. Again 0 0 0, no state. Again remove 0 0. 0 is nothing but the default state. So whenever the 0 is detected, we are going into the S0 state. But when 1 0 0 1 is detected, so if 1 0 0 1 is detected, that means our output is going to be high. But what is going to be our next state? Start removing the bits from starting. Remove 0 0 0 1, no state. Remove 0 0 1, no state. Remove 0 1, yes, S1. So if we are in S3 state and 1 is detected, our output is going to be 1 and the next state is going to be S1. And if our next state is S1, that means 1 is detected. That means if there is again 0 0 1 is detected, that means this 1 will be part of both the sequence. So this is nothing but an overlapping case. So guys, this is how the state diagram of Mealy FSM with overlapping concept looks like for 1001 sequence detector. I hope this is clear. And here if you see the Verilog HDL code, so here only the change is going to be when data input is high, when we are in S3 state, the next state is going to be S1. Otherwise the next state is going to be S0. So this is the only difference in the Verilog HDL code. Otherwise it is all going to be same. So friends, I hope the concept of Murray and Mealy FSM for 1001 sequence detector for both overlapping and non-overlapping type of FSM is clear to you. If you have any doubts, please write down in the comment section. Also, if you like this video, please hit the like button and do not forget to subscribe this channel so that you would get notified as soon as I upload the next video. Thank you very much.